Hello everyone. In previous lecture we have studied Faraday's laws of electromagnetic induction. The next part in this chapter is self-inductance. In previous lecture we know about the Faraday's experiment. Then we have to started a self-inductance. When a current through a loop in a switched on, the current in the loop increases from 0 to the maximum steady value I0. In that experiment, when a current passes through, then the tab key or the circuit is a switch on. Then the current is increases from loop, that is 0 to the maximum steady value I0. As the current in the loop is increases, the magnetic field linking with the loop itself also increases, and hence is an increase in the magnetic flux linking with the loop. As the current in the loop is increases in that circuit, that the magnetic field linking with the loop is itself and also increases, and hence increases in the magnetic flux linking with the loop. Therefore an EMF is induced in the loop which opposes the increases in the flux is also called self-induction. EMF is induced in the loop which opposes that current which passes through this loop. This is called the self-induction. When a key is not tapped, then the switch is when the current is switched off, the current decreases from I0 to the 0, and flux linking with the loop itself also decreases. Hence an EMF is induced in this loop is also decreases, which opposes that the decreases in the current. This induced EMF is also opposes the change, that current is also called as the back EMF. When an instantaneous current through the loop, then the magnetic flux linking with the loop, which is also noted as a phi, is directly proportional to I. Then proportionality constant is removed, which gives a phi is equal to L into I. L is also called as the proportionality constant or the self-inductance. Then we get phi is equal to, if we put I is a current is equal to 1, so self-inductance of the loop, L of the loop, is defined as a flux phi linking with the loop when it carries a current I. Self-inductance of the loop in that circuit is also defined as a flux phi of the linking with the loop when it carries a current 1 ampere. Then we differentiate phi with respect to the time. Then equation gives also d phi by dt is equal to L into di by dt. We are simultaneously change with the current, that is di by dt. But induced EMF in this loop is also opposes the which opposes the current, that gives equation is also in a negative sign, that is E is equal to minus d phi by dt is equal to L into minus L into di by dt. This equation is also called as this equation gives an induced EMF. Thus when a current is increasing, di by dt is positive. Therefore an induced EMF is in a direction opposite to the original current. Hence the current grows slowly and the circuit is switched on. On the other hand, when the circuit is switched off, the current is decreases. Hence di by dt is negative. Therefore induced current flows in the same direction as that of the original current, that is current decays very slowly. When the circuit is switched off, then the current is decreases, hence di by dt is negative. Therefore the induced current flows in the same direction as that of the original current, that is current decays is very slowly. We put E is equal to L. Then if di by dt is equal to 1. So we can define self-inductance of the loop as an EMF induced in the loop when a current through it changes as the unit rate. Unit for self-inductance in the SI system is the Henry H. Self-inductance of the loop is said to be 1 Henry when the current through the loop changing at a rate of 1 ampere per second. So the self-inductance of the coil depends only on the geometrical dimension, that is the shape and size of the loop and the medium inside the loop. We put an example of the self-inductance. Self-inductance of the solenoid, that is conducting wire wound continuously on the non-conducting frame, can be calculated as magnetic induction in the interior of the solenoid is B is equal to mu 0 Ni, where N is the number of the turns per unit length of the solenoid. If A is the area of cross section of solenoid and then flux linking with the each current, that is 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 equal to mu 0 N square A.